My name is Harsh Patel, and I'm a senior FAE. I'm located in Detroit and focused on the automotive side of the business in Amphenol Communication Solutions. So I want to start off with showing the trends that we have ongoing in automotive, right? So, we started with the one port, looking back at 2008 when we used the OBD, and looking at where we are today. At less than probably 10 ports to probably about 100 ports in between there, and where we're headed, right? So the number of connections that we have in a vehicle are significantly increasing, and there's no surprise that it's just going to continue on this path, right? As we talk about cameras and gateways and ADAS and autonomous driving in a vehicle. So. And especially when we're talking autonomous, there's levels of autonomy, right? So I'm gonna share that in the next slide here. So when we talk about levels of autonomy, we have level 0, which is pretty much the driver is completely engaged with the vehicle, completely controlling the vehicle, and then as you move to the levels 1, 2, 3, 4, and 5. You're getting assist, basically in terms of features like lane assist, adaptive cruise control, and so on, right? So right now, we're not all the way up to level 5, but that's our goal and that's our path. So as we move, from each level to level, we're going to see an increase in the number of components in a vehicle, the number of features and whatnot, right? And that's where the levels of autonomy come into play. And this is an interesting fact that I actually found very interesting when I first heard about it. Third heaviest component in a car is actually all the wiring harnesses combined. And you can kind of imagine why, right? We just seen the trend, with all the features being added in a vehicle. So if you were to look at all the features, somewhere, somehow, a connector and a cable assembly is going to be connecting some module or some camera. And that's where this is coming up as a fact, but it's right behind the engine and the chassis. So if you were to add up all these cable harnesses, that's the third heaviest component in a car, which is really fascinating. And we're in the right business, I guess, too. Yeah, this is a good slide. So this was actually shared by Kirsten Matthews in Automotive Ethernet Congress in 2019. It's really showing you all the different networks that are in a vehicle, and everything from low speed to high speed. And you'll notice things like CAN, LIN, MOST is all FlexRay is all on there. And then the high speed stuff, the Automotive Ethernet, which is being focused right now, right? So you'll see the 1 gig, the 2.5, 5, 10 meg, and 25 gigs and beyond, right? As well as the SerDes and USB and HDMI and all those links as well. So today, primarily, we're going to talk about the high-speed side of the automotive side. So we're not going to go into too much detail on the low-speed stuff, but this is a great overview, and this is just a glance at what type of networks are in a vehicle. So as you can imagine, the challenges that come, when you're talking about these in a vehicle, you can kind of imagine, SI is one, but there's EMI, EMC, and we'll discuss some of those challenges as we go. But this is a great slide just to show you some of those stars that you see on the screen are basically what we're working on today. The Automotive Ethernet is the focus. So I'm going to break them down into some high-speed protocols, right, that we were widely using in automotive today. So LVDS, low voltage differential signaling, USB, Automotive Ethernet, DisplayPort, ASA, A2B, MIPI, HD-based-T, PCIe, and the list goes on and on, right? But I'm going to be talking about those grouped in some categories, and then the main, two aspects that we need to discuss and understand, right, from the SI requirements, and then the other one is EMI EMC, and the EMI EMC one is just from now in standards work, it's becoming more and more critical as we increase the speed, and we're talking really high speed in automotive as well. Not for datacom, right? Datacom, you guys are talking 100 gigs and beyond, but for automotive, traditionally, USB was considered high speed, right? So it is a big deal when we start talking about 2.5, 5, 10, and now we're talking about 25 gigs and beyond, right? So it is getting fast, and the EMI EMC becomes very critical. And the other part is, being in automotive environment, you're basically going to have to consider things like the environment, constraints. So there's requirements that come from automotive standards as well as the OEM specs, right? So things like thermal shock and thermal aging and vibration and all that has to be basically done on your components. So connector, cable assemblies, and they have to meet certain requirements like US car, LV214, and etc. And sometimes there's additional requirements from the OEMs as well. And what I mean by OEM is, the main car manufacturers, right? So you got GM, Ford, Tesla, all these guys would be OEMs. All right, so first one that we're going to talk about is the LVDS, right? So LVDS, like I mentioned, it stands for low voltage differential signaling. And previously, you have some big players like TI, Innova, Maxim with their proprietary LVDS chipsets, right? And these were great and they were widely used for displays. And right now there's ongoing efforts at ASA, which is Automotive SerDes Alliance, and they're trying to standardize, kind of make it like IEEE, but for the SerDes market. And this is going to be for asymmetrical PHYs, basically. So that's ongoing effort, and there's a lot of participation and acceleration. And this was kind of initiated by Kirsten Matthews from BMW, but there's a lot of key players on there now. And then I put in there GVIF, which is a spec by Sony, and gigabit video interface as well, because it kind of plays in the same space as LVDS. So when we talk about these LVDS specs, you should keep in mind those two things that we discussed earlier, right? So, SI requirements and EMI/EMC. So again, talking about the proprietary links from TI, Innova, Maxim. There's something called the channel requirements document, right? That tells you what exactly do we have to meet for the connectors or cables, right? And the SI requirements or EMI/EMC requirements for the channel to work, right? So similarly, that effort is going on in ASA, but it's at a higher level, right? It's generalized. So all the manufacturers of the ASA spec would have to meet those requirements. And so, it's kind of a interesting perspective from OEMs, but that's going to help them a lot, basically, from a sourcing standpoint. All right, so next one is the big one, Automotive Ethernet. This is very kind of the future, and this is one that we all agree on. In automotive, right now, there's a lot of standards and specs out there, activities, parallel activities, where things are maybe not so clear where they're going to end up. But if you look at Automotive Ethernet, everyone believes that this is the future in the vehicle. And these are some of the standards that I want to highlight, because if you start from the 100 base T1, I've kind of put commas and then I've listed everything, because you could say any of that and it means the same thing, right? But in Ethernet, we have IEEE and then we have Open Alliance. So IEEE, we talk about the full channel spec and we develop that. Open Alliance usually takes that specs and then we go into detail in TC9 group, right? So we make limits for component level, the connector only, cable only, and we have the channel, of course, but the channel would be the same as IEEE. And the purpose is that we all test the same way. So, regarding supplier A, B, whatever, if you're testing a cable connector to meet the 100 base T1 or 1000 base T1, you would refer to the Open Alliance spec and look at the component level, and the testing would be really nicely detailed, defined in the spec, so you can test it the same way. And so that's the activity kind of happening in both of the areas. So 1000 or 100 base T1 would be, the IEEE 802.3 BW, and then the broader reach would be the name that the Open Alliance has. So 1000 base T1 was a unshielded spec, and shortly after, there were a lot of customers basically having issues in EMI/EMC, and that's where shortly after we created a STP version of the spec, where some of the parameters of SI were adjusted, and for example, mode conversion, and we removed that and we added shielding parameters like screening attenuation and coupling attenuation. So that was kind of targeted, and right now in vehicles you would widely see 100 base T1 and 1000 base T1 as an implementation and moving towards the automotive Ethernet. 10 base T1S and T1L, they stand for short and long. And this is actually going in the opposite direction, so getting slower, but the main reason is to target some of the lower speed applications that we looked at. From that picture that we saw earlier. So things like CAN, LIN, those are actually being replaced by 10 base T1S and L. So that's kind of the goal there. So when we do switch over architecture completely to an automotive Ethernet, those networks would ideally get replaced by 10 base T1S and L. The other spec that just got released recently was the multi-gig Ethernet. So that's the 2.5G, 5G, and 10G automotive Ethernet speeds. And this one is completed, and its ongoing efforts are ongoing right now as we speak. So basically, it's at the point where OEMs have to pick a PHY vendor and connectors and whatnot, and you should probably start to see it in vehicles as early as 2024, 25 is probably when you should start to see those networks. And then currently, the ongoing activity in IEEE is 10G and beyond, right? So 25 gigs, 50 gig, and 100 gigs. And this is called greater than 10 gigs automotive Ethernet. And this is ongoing right now, so there's not a lot to say there, but it's basically not concrete, anything we discussed there. But that's kind of where we're at right now, and it's going to be over one lane, 25 gigs, and then the 50 gig, 100 gigs, we don't know yet, so we'll see where that ends up. So talking about some of the other various protocols, as you saw, that picture was very heavy with a lot of other stuff like USB and whatnot, right? So A2B is the audio bus. It's daisy chain, single twisted pair. So super low cost, is used in audio applications. It's bidirectional data bus and supports basically with no jitter and very extremely low fixed latency. So really good benefits there. DisplayPort is widely used for the display applications as well. It's part of the VESA standard. There's a MIPI standard, mobile industry processor interface, and there's an automotive, spec I think there for MIPI as well, and they pretty much deal with everything. So from high-res cameras, lidars, radars, sensors, information control entertainment displays, and everything pretty much, right? So there's that one, and HD-base-T is sort of similar, but they deal with kind of tunneling data of a variety of protocols. So you might have video, audio, Ethernet controls, USB, and 100 watt of power over a single cable. So the benefits of HD-base-T is basically tunneling data. And then you have PCIe, which is also looking at automotive PCIe. That's coming up more and more. There's a standard actually dealing with that as well. And then USB 2.0, which is legacy, and then the USB 3.0. Mainly used for consumer ports. That's widely the application for those. So I mentioned architecture a couple times, but what we're talking about when we say architecture, currently the cable, I mentioned cable is the heaviest component. The reason is every time we need like a display and we connect from one point to the module or something, it's all point-to-point connections, and they're very long, right, in the vehicle. So they may be as long as 10 meters, 15 meters, and that's the type of requirements we have in automotive Ethernet as well. But now we're starting to go from the traditional architecture to the zonal architectures, right? And what that means is we're going to have switches and gateways in a vehicle, as you can see in the image on the right. And that's going to reduce the overall cable lengths that we're using, as well as it's going to reduce the weight and complexity and just implementation, right? But it is going to increase the number of maybe ports that we have, right? Just because of the trends that we're seeing, the features that we're adding, just to make it level 5 autonomy. We are going to see that trend, but this is kind of where things are moving, right? And it's not going to happen at a flip of a switch. So things are in that transition now, and every OEM might be at a different point in time, right? So you might see some OEMs maybe closer to that zonal architecture than others, but depending on where they are, they're gonna be in a transition of using automotive Ethernet more than others, right? So that's kind of where things are at. And then the other protocols that they might be using for LVDS or ASA, those are all happening in parallel, and there's conflict obviously, because there's gonna be position from the LVDS traditional players, right? They're gonna try to keep their space, and ASA is trying to generalize it, so they're going to be, there's just conflicting specs out there. So now it's going to be interesting, what plays out. But automotive Ethernet is one thing from this architecture shift that it is going to happen. So this is actually why 10G and beyond, right? So these are some points that we actually had in our CFI for IEEE. So talking about what are the reasons why we need beyond 10 gigs, right? And maybe it's not so clear looking at vehicles today, but what we're working on and going to autonomous, like it basically is required, and we're saying some of these facts actually are outdated by now. So I'll go into a little bit of detail. So yeah, transition from the traditional architecture to the zonal means that there's going to be redundancy involved, and that means that we're going to have a lot of data flowing from the gateways and switches. So that means we do need higher bandwidths in those links. Autonomous driving, basically the sensors, right, is going to collect uncompressed data. So that's, again, a reason why we will need the higher bandwidth. There's going to be something like a black box that we hear about in planes. So similarly, we're going to have that in the autonomous cars, and that's going to require significant bandwidth as well. And then that fact is actually outdated now. The 4 terabytes of data collected every day, it's probably close to 6 to 8 now, and that's just because from the time we had the CFI to now, they were kind of estimating wrong, right, based on the features that we need and how much data is actually collected. So anyways, it's close to 6 terabytes of data in one vehicle in just per day. So pretty heavy data that's going to be collected and used in the vehicle just to have this autonomous feature. And OEMs are actually using enterprise class automotive Ethernet in the vehicles at the time, right? So that was another big reason why we needed to start on the automotive Ethernet for the higher data rates, which is the 25, 50, and the 100. So these are actually some of the challenges that we have in automotive right now. If you look at standards, or if you were just to look at the industry, right? So EMI is one of the key problems, and you can kind of imagine why, right? We talked about so many standards or specs here or protocols, and they're all very in close proximity in the vehicle, being routed together, sometimes in a harness or just module to module, right? So EMI, EMC is going to be your biggest level of difficulty, talking about these high data rates and connectors, cables, everything. It's gonna be your shielding, right? So not only you wanna make sure that the signal is not cross-talking with the other signals nearby, but also from the environment affecting your your systems as well. So EMI, EMC is very critical, and latency is going to be another one, right? So talking about delay, you cannot have certain amount of delay when you're saying the car has to decide on braking or something critical like that. So safety related items, so handling failures safely is another one, right? Another big item that you almost need to detect failures before they happen, right? So you're going to be continuously looking at that data and processing it. And Ford actually did a really interesting presentation on this regarding EV, their Mach-E, right? And how they actually take this basically data, and before there's fault in the battery, and before something like a disaster happens, like a fire or something, right? They're able to tell the driver to basically not use the vehicle or safely bring it to them, right? So there are data-driven failures being safely handled that way, right? So that's going to be a next big challenge as well when we start talking about safety critical applications. And weight is another big one. As you can imagine, Third heaviest in the car is all just cable harnesses, right? So we do have that big factor in mind. So we do have to reduce the cable lengths, and the architecture shift is helping in that manner. But you are also adding other components, right? Switching from the traditional to the zonal architecture, you are adding switches and gateways, right? So it's a trade-off, but it's a good one because there are things that we need to do, right? For example, adding the features for autonomous, we do need the zonal architecture, so that's where kind of the weight trade-off is pretty on par with what we're currently doing today, but it is a challenge that, that they're going to look at. And that's all I had for today. So if there's any questions for me, either today or whenever, you guys can always reach out, and feel free to ask anyone in the booth as well for our automotive contacts.